Hello, welcome to lesson 1.4. So just a quick note, how these applications are going to be graded. If you have no work shown or the files type didn't make it or there was an upload error, I'm going to give that a 0.1 for the grade and then also give you feedback. That way there's two things that are just going to kind of flash out at you as, oh, there's an issue here. I need to solve this right away because I might be getting late fees at this point. So since you guys are in high school, really, as soon as you submit, check and make sure through the preview or re-downloading the link that your file did make it there and there's no glitches. If you use an Android phone and it gives you an HEIC, Canvas does not accept those. So just get in the habit of putting everything in a PDF if you're using pictures. Okay, and then I will regrade it once you resubmit that sometime in the next couple of days. Okay. Now, how do I do grading? If you try every problem and show your work on every problem, every single problem, but you have some issues and you can't quite figure out what you're doing, you're going to get a 70% on that. And then you can resubmit it if you want to improve that grade. Now, if you try every problem and you identify everything correctly, so you told me that 10 meters per second was a velocity, and then you gave me the equation that you are using, just you might have gotten off track, okay, then you get an 80% minimum on that. If you try every problem, your setups are correct, and maybe it's just like a calculator error or a plus minus issue, or you forgot to write your units down, then that would be a 90%. So just small little problems, but you're telling me, you're identifying the knowns and unknowns, you're telling me the equation, you're showing the work, then that would be a 90%. Okay, and so this is my format. You do not have to do this format. It just helps you make sure you're not forgetting any of the work. You want to identify your givens, which are your knowns, the numbers of the equation. You want to identify what's the unknown, what you're finding. And you literally want to say velocity final equals question mark so that it sinks in your brain. If it's a dimensional analysis problem, you can do that all in one step and say known equals question mark unknown. But if it's an equation, then you do want to make sure you're identifying each one. This can be by circling it if you printed out the problem, or circling it if you're using any of the online programs, or you can just physically write it in your notebook, velocity initial equals 5 meters per second, and just make sure you're identifying each of those. If you do it that way, you don't have to write out the whole problem if you're not using online or a printed copy. And then tell me what equation you're using, and then substitute in that equation and solve for that equation. Okay, so you don't have to show me your work on how to multiply or divide. You can use Desmos for the whole long equation, but do show me the long equation with variables and the long equation with items substituted in. So let's do a practice one so you can see what I'm doing about guess, and then just make sure you have all the things identified, but you can use whatever process you want. A graduating senior throws their cap in the air and it reaches a maximum height of 5 meters. So I'm going to circle that. I'm going to put a D for distance. How much time? Okay, that's a question, right? So that is my unknown, and that's time that we're looking for. Does it take to reach that height? So what information do we have? There's a lot of extraneous information here, right? This is how it helps us break it down. Okay, we did our given and we did our time. So what do we know? Okay. And now what equations could we use? So we got to think about it a little bit further. Okay. Even though it didn't say it, was there more information? We know our initial velocity is not 0. Why not? Because we threw it up in the air. So we gave it an initial velocity. So it is not 0. Okay. After I released it, I'm not in charge of that anymore. I'm not accelerating it. Who is accelerating that cap? Accelerating due to gravity. So on the way up, gravity is pulling it down and decelerating it. And then it's going to reach that top point where the velocity is 0 because it's slowing down and then it's speeding up. So at that very top, that final velocity would be 0. So the velocity final, or the velocity at the top, would be 0. Okay, and the acceleration would be gravity. So even though it wasn't in there, we had some more identifying to do. And then when it hits the ground, it's going to stop moving there too, right? So the velocity final there is also 0. So if you ever get to the equations and you're like, whoa, none of these equations work, go back and think about it. What assumptions can I make from that information? So now I have a little bit more information that I can work with. I have the velocity final of 0, the distance of 5 meters, and the acceleration of negative 9.8. I'm throwing it up, and gravity is pulling it down the opposite direction. What are the unknowns? What am I trying to find? Time. But to find time, I'm probably going to need to find that initial velocity as well. So I have 2, even though it didn't mention it. So sometimes it's going to take multiple equations to solve. Okay. And get out your equation sheet. I do have it written right over here. And the same thing that we did over there, circling the knowns and underlining the unknowns, we can do right here. With our equations that we write down. Okay, so you could put your equation sheet in to sheet protectors and use Expo over the top, or you could rewrite them, which is going to help you memorizing for the SOL. All right, or some of you might be able to just look at it and say, oh, nope, I need to use this equation. But if you're having trouble when you're looking at the motion equations going, which one am I going to need? This same system is going to help you. All right, so we have velocity finals. So I'm going to circle all my velocity finals. There we go. We know distances. So I am going to now circle all my distances because we know those answers. What's next? Acceleration. We know it's due to gravity. So I'm going to circle all those accelerations. Right. And now I can go through and look at each one and go, okay, so on this first equation, I need average velocity and time. So I'm probably not using that guy. This next guy, need the change in velocity and time. Probably not using that guy to solve. Next guy, again, initial velocity and time. Too many variables to solve if I only have one equation. Initial velocity and time. So my first equation that I'm going to use is going to be this guy down here. Why? Because there's only one variable. There's only velocity initial in that one. It's velocity initial squared, but still only one variable. So I have the velocity final. I have the acceleration. I have the distance. So I can solve for velocity initial. And now when I go back, can I find a better answer? Yep. Can I use first equation? No, that's average velocity, not starting and ending velocity. Change in velocity, could I use that one? Sure. I just have to find the change in velocity, velocity final minus velocity initial. Is there a better one? Yeah, maybe I would use this guy down here because it's already been separated out for me. So the second equation I would use is this guy. That's how you use that to sort and find the equations. So today we only have 1, 2, 3, 4, 5 equations. At the end of the year, you're going to have the whole formula sheet that you're going to have to figure out, okay, which equation am I going to use here? So just get in that system now of finding your best equation. And have a great day.